Okay, so we are going to be starting a set of lessons covering things called a matrix or matrices for plurals. Yes, we're going to be looking at the Matrix today, and I'm not talking Keanu Reeves, although if you haven't seen that, you probably should. It's a great movie. Okay, all right, so let's talk about what is a matrix. A matrix, let's give just a definition. It is a rectangular array of variables and we'll say and or constants organized in rows. And so we'll put a little left right here to remind ourselves that rows run left right. So it's organized in rows and columns. And of course our columns run up and down. So we've got to be clear when we talk about rows, we're talking about a left and right organization. When we talk about columns, we're talking about an up and down organization. Okay? So this is what we're talking about, a rectangular array of variables and or constants organized in rows and columns. Now, usually you will see a matrix written on a piece of paper looking like this right here with brackets surrounding them. You can see another matrix down the bottom. Usually we write brackets around those. Of course, we're working with formative, and formative is not at the level yet of high school math where we can do matrices. So it's actually going to look on formative a lot more like this. Well, really, this is actually what we're doing. A matrix, if you think about a spreadsheet, it's just rows and columns, and it's a place to store data. That's what a spreadsheet is. And then when you get good at working with spreadsheets, you can manipulate the data. You can have different places where you store data. You can do things with that data. Like I could take one set of test scores into one spreadsheet and another set of test scores into a different spreadsheet and a third set of test scores into a different spreadsheet organized by your name and the test number. And then I could take all of those and then write a special math code, and it would multiply all those numbers together and divide them by 3 and give me your average test score. That's really what goes on in computer programming. So what we're going to be looking at with matrices is kind of spreadsheets by hand is really what we're going to be looking at, is this idea of how this works, okay? All right, so let's go back to what we're talking about here. Now, inside each matrix, there are what we call elements, and elements are the individual items that live within the matrix. These are these individual items, these individual pieces of data that are organized into rows and columns. Okay. Now, we're going to use a little notation here. I'm going to use, and again, I can use any letter I want here. I'm just going to choose A to be consistent with the notes that were being given here. Okay. But I'm going to just choose A. And so here's how we're going to notate it. Just like we did with our series and our sequences, I'm going to notate this with a little sub notation. So I'm going to say A sub X Y. A sub X Y. So I'm going to have two numbers down the bottom. And this A sub X Y is how I'm going to indicate which piece of data I'm talking about in the matrix. Okay? And so the way this works is I'm going to denote X as the row number and Y as the column number where the element is located. And let's just put a little special note here. We're always going to start with the upper left item. So when you look at a matrix, you're always going to start with the upper left item. And again, you're going to think of these in terms of being numbered. So we'll just do this one time just so you could see it. So this would be row number 1, row number 2, row number 3. This would be column number 1, column number 2, and so on and so forth. You get what I'm doing here? Okay, right? And so if I said to you, tell me what is element A sub 25, then you would look for the element in row 2, column 5. Well, where's row 2, column 5? Yeah, so you would go all the way over here, row 2, and then you would identify column 5, and you would say the meeting point of row 2 and column 5 is right there at -2. So the element A sub 25 is equal to -2. This would be the kind of thing like you would like tell a computer, go find A sub 25, and it would go and pull that piece of data from that location in the matrix or the spreadsheet. Okay? All right. So A sub 31. What is A sub 31? Yeah, it's 5, right? How about A sub 12? Okay, A sub 12, you should have put 40. How about A sub 34? A sub 34 is going to be 52. Okay, you do the last two. Go ahead, write them down. All right, you should have written down 21 and 32. How'd you do? Good? All right, now you can find any element in a matrix. Okay, good. So now you're working with matrices, already working with them. Look at you go. Okay, so you can identify rows, you can identify columns, and by knowing how many rows and columns there are, I can ask you to find a specific element number, and you can go and get that element and withdraw it just like a computer. Okay, all right, now let's talk about the dimensions of a matrix. Now, the dimensions of a matrix is super important that you get this order right. Is always written rows by columns. And again, I'm going to just indicate this here is the word by. This is not times, okay? We're not calculating a math problem here. We're using this as a symbol to say by. I have rows by columns. Like, for example, in the first one up here that we were just working at, I have 3 rows and 5 columns. That would be a 3 by 5. Not a 5 by 3. That's different. It's a 3 by 5. And what you're going to find with matrices is the order of the numbers matters. We cannot change that up, okay? We cannot change up the positioning of the things within the matrix. That matters what we do here. All right, so let's write this down just so that we have it. So we will say a matrix with M, put that in quotes, M rows and N columns is said to be an M by N matrix. Got it? I'm going to give that like 15 seconds and I'm going to lose my brain. Okay, so let's talk about number 7. What are the dimensions of number 7? Yeah, this is a 1 by 3 matrix. It is 1 row by 1, 2, 3 columns. It's a 1 by 3 matrix.
I understand.
Okay. All right. How about number 8 here? What are the dimensions of number 8? Okay. This is a 4 by 2 matrix. So when I ask you to find the dimensions of a matrix, you're going to tell me rows by columns, and you're going to use the times sign to do that. Not an X on the keyboard, the times sign, which is different in our math keyboard on formative. And we'll practice that. All right, you do 9 and 10. Go ahead. I'll give you 10 seconds. Go ahead, 9 and 10. All right, you should have put a 3 by 4 and a 2 by 6. How'd you do? You got that one? Everybody good? Yeah, yeah? Let me see. Let's see. We're good? Okay, so now you can describe a matrix by its dimensions. So you know what a matrix is. It's a place where we store data by rows and columns. You can now find an individual element in the matrix and you can describe it by its dimensions. All right, good. Okay, so these are just some special case type things that show up in math. Some of them will show up for us, some of them will not. Let's talk about equal matrices. So equal matrices are two matrices in which each corresponding element each correspondent is equal, are equal. Okay, so matrices are usually named with a capital letter. You can see up here, I'll come back to that in just a second. You can see up here that this is matrix capital A. Okay, so matrices are usually named with a capital letter. So if we were to say, we would say, if matrix A was equal to matrix B, then, and this is just going to be an example, we could say something like A sub 2, 1 is equal to B sub 2, 1. And I'm going to write etc. because each element in the matrix would match. See what I'm saying? So the element that's in position 2, 1 in matrix A is going to be the same as the element that's in position 2, 1 in matrix B. That's the corresponding aspect. And all those would be the same if the matrices themselves were in fact equal. Does that make sense? So if I said something to you like matrix A is equal to matrix C and element 3, 5 in matrix A is what is element 3, 5 in matrix C? See how I phrased that question to be completely confusing? And yet it's really simple. It's whatever I said it was here is there because I told you the matrices were equal. Got it? Okay. Again, this is like speaking my language. Okay, good. All right, here's some special matrices. This one's called a row matrix. It looks like this. Okay, a row matrix is a 1 by. Actually, here, let's do this. We'll do it with a variable. This will be better. This will be better communication. We'll say 1 by. And then there's a column matrix that looks like this. So this is a by 1. In other words, I could have as many rows as I want as long as I have one column. I would call it a column matrix. All right, now this one will absolutely show up a lot. This is an by Whatever number of rows I have is the same as the number of columns I have. This would be a 2 by 2, or a 3 by 3, or a 5 by 5, or an 11 by 11, or a 219 by 219. The rows and the column numbers, the amount of them must match. And then there's this guy. We call this a zero matrix.
0, 0, 0, 0. Does it have to be 3 by 3?
Nope. Basically, all it has to be is all elements equal to 0. We could jot that down here. All elements equal to 0. They said, well, why would we have that? Well, there's reasons for this. We'll get to them as we start doing some math. All right, how are we doing so far? Everybody can identify a specific element. You can name a matrix by its dimensions. You're aware of some special cases like if matrices are equal, the elements are the same in their corresponding places. You can identify whether a matrix is a row, column, square, or 0. Good? Okay, let's keep going. Backside. All right. Now, okay, so the whole point of being able to collect data is do stuff with it. That's one of the things that we want to be able to do. We'll start simple and easy with addition and subtraction. Now, okay, this is super important. Don't miss it. Matrices can only be added, it says right here, if and only if, box, highlight, underline, double star, whatever you need to do. Matrices can only be added or subtracted if they have the same dimensions. So there will be addition and subtraction problems given to you where you'll have to answer, not possible. Because I'll be asking you to add or subtract matrices with different dimensions, and you'll have to say, I'm sorry, Mr. Vargas, that's against the rules. You cannot do that. Okay. Let's try one. Actually, let's do this just to make life easy for ourselves. Yeah, well, easy. Oh, that. Yeah. Okay. All right, here's what I want you to do. Above each one of the matrices, like right up here and here and here and here, I want you to write the dimensions of the matrix. So what are the dimensions of matrix W and X and Y and Z? Write those dimensions up above there. Go ahead and do that right now. All right, you ready? Should have put 3 by 2 for W, 2 by 3 for X, 2 by 3 for Y, 3 by 2 for Z. All right, let's talk about adding matrix X and Y. First off, can we do that? Why can we do that? Because they're both 2 by 3 matrices, so I'm going to put a little check mark just to make sure that I check that I can do that. All right, now, when I do that, what I'm going to do is I'm going to add the corresponding elements. Now, when you're writing matrices down on paper or showing your work, I do want you to use the bracket notation, okay? So let's set this up here. Now, one thing we know already is that if we're taking a 2 by 3 matrix and we're adding it to another 2 by 3 matrix, what is the result dimensions going to be? Well, we're just adding each corresponding element. It's going to be the same, right? It has to be the same, right? Okay, so in this case, we're going to have another 2 by 3 matrix, okay? Because what we're going to do, and sometimes this will be helpful a little later on. Maybe this is helpful for you. Watch. I'm just going to do this right now. Okay, so here's how this is going to work. Okay, watch this. This first box right here is going to come from the sum of x11 plus y11. See what I did? So then I'm going to add 24 and negative 15. And what's the result of 24 plus negative 15? Positive 9 goes in the new matrix answer. Get it? Okay, we'll do this just one more time. So this second one is going to come from x12 plus what? y12. This is going to be helpful later on. When you understand what I'm doing here, this is going to be helpful later on. Okay? So understand where the math problem comes from will help you keep track of things. All right, so negative 8 plus 29 is? 21. Okay, all right. So then what would be the math problem for the third one? This will be the last one. Yeah, this is going to be x13 plus y13. Okay, why don't you fill out the rest? And actually write the math problems down the bottom for the bottom one. We won't do this every time, but we'll just do it on this problem. So we have it sort of like notes. Okay, go ahead, finish it up. Okay, here we go. This is what you should have come up with here. And did you get the right math problems? Yeah. Yes? Okay. All right. So, okay, let's talk about the next one, number 12 here. So, Z minus W, matrix Z minus W. Okay, question number 1, can we do that math problem? Why?
Because they have dimensions.
Okay, they have the same dimension. All right, so let's put a little check mark because we know we can do that. All right, so what will the dimensions of our answer be? It's still going to be a 3 by 2 because when we're adding and subtracting, we're just adding and subtracting the individual elements, right? So we know that we're going to have a 3 by 2 matrix. I'm going to write it over here, okay? And if you want to do the circles, if that's helpful for you, you can do that, or you can just write in your values as long as you keep your 1, 2, 3 rows clear from your 1, 2 columns. All right, I'm going to let you do this one on your own. Watch out for subtraction problems. Remember, when you subtract a negative, it becomes a positive. Okay, here you go. Take a look. How'd you do? You got them? Yeah? Okay, I want you to do 13 and 14. And only 13 and 14. Go ahead.
What?
13 and 14. Go. Here's what you should have come up with for 13 and 14. How did you do?
Great.
Yes?
Yes.
Okay. All right, so let's talk about some other math that can be done with matrices. So this is called scalar multiplication. Okay, well, it's really not that confusing. It's scaling by multiplication. We've done this before. Making triangles bigger and smaller. Multiply by a number greater than 1, triangle gets bigger. Multiply by a number smaller than 1, triangle gets smaller. Okay? Multiply by 1, it stays the same. That might come back. All right. So let's do this. For this first one here, okay, we're a little bit off focus. Let's focus back in. Okay, for number 15, what you're going to do is you're going to think of this coefficient as almost being written like right next to the bracket out here in terms of a multiplication problem. You know how we write multiplication right next to a parenthesis? You could almost, and you will in the future, see numbers written right out in front of these matrices, and that's a sign of scalar multiplication. And what that means is you're going to take each element in the matrix and you're going to scale it up by 3. So you're going to take each element in matrix X and you're going to multiply them by 3 and to come up with one answer. Now, question. What will be the dimensions of the answer to problem number 15? It's a 2 by 3, right? You're just taking a 2 by 3 and multiplying each of the elements by 3. So it's not changing the rows or columns. You're just changing the values inside. It'd be like if I, curved a test, which will never happen in my class. Like that kind of a thing. I'm just giving you mathematical examples of real life situations. That's all. Okay. All right. Go ahead and do number 15. Go ahead and do number 15. I think you guys should be good here. Yes, right? Got the scalar multiplication? Okay. All right. So let me just give you a couple tips, and then I'm going to have you finish what's on this paper. Couple of things to keep in mind. Okay. So this question number 17, you're going to scale matrix X by -5, and then you're going to scale matrix Y by +2, and then you're going to add them. Order of operations, right? Now listen, there will be questions, just like on all of our formatives, where you type in your answer, but I'm still going to expect you to show work to support your answer. So for questions like this, a natural step of work, one level of work for you to show me would be the scaling of matrix X by -5 and the scaling of matrix Y by +2 so that I can see what you came up with here and what you're adding here to get your answer here. Make sense? Yeah. That's what I want to see for work. So for questions like 15 and 16, I don't need to see any work because you're just multiplying by an individual scalar. But for questions 17, 18, 19, and 20, I need to see at least one level of work. You've got to show me the first thing you do and then how you get to your answer. Okay, and I'll expect that on formative as well. Okay, all right, I'm going to let you finish that. We'll take a few minutes. I'll gauge the process of the class, and then we'll take a look at some homework together on our formative. All right, you're working on the rest of these 15 through 20. Okay, I'm going to put the answers for 15 and 16 up on the board just so that you can check your work as you're going along and make sure you're tracking. So there's 15 and 16. All right, here is 17 and 18 for you to take a look at. All right, let's take a look, see how you did. Check your answers for 19 and 20. You should have in front of you lesson 14 homework, intro to matrices. All right, look at this show going. Okay, now before we jump in, you should have some instructions in front of you right now, correct? Yeah. Okay, let's go over these instructions to make sure we're clear. Number one, you're going to use, are you listening? If you're talking, you're not listening. Okay. You're going to use the time sign on the math keyboard as your by indicator for like your rows by columns. Don't use a plain old X. Use the time sign or you won't get that correct. Number two, for matrices questions involving math, you will have to determine how many elements are needed for the answer boxes provided. In other words, every answer box might not be needed. You're going to always start with A11. That would be your upper left-hand corner, right? Row 1, column 1. And then if there's not supposed to be an element in the answer box, you're going to type NA. We'll get to a question like that, and it'll make more sense when you see the question. And then again, for fractional answers, you're going to use a simplified, proper, and or improper fraction. No mixed numbers, okay? No decimals. Oops. Oh, I should have put those on the screen. There you go. You guys are looking at them, though, right? Okay, good. All right, that's all that matters. All right, let's go to... All right, so you are going to give the dimensions of each matrix in the show your work section. So you're just going to open the show your work section. And by the way, if you get like annoyed by that little, here, watch, I'll show you this thing. Like where like it pops up and says draw images or add things here and it's like cluttering your way. Just put a little teeny dot right above the box and that'll clear that out of the way. And then that way you can kind of zoom in and type in your dimensions. Okay? So you're going to type in the dimension. I just anywhere on your screen, but I just put a little teeny dot. It just when you write on there, it clears it. Now don't put it way away. It's going to make it super small. We talked about that. Okay, so you're entering your dimensions. Go ahead and do that. You have a group of matrices here, of which you can write your dimensions on, which might not be a bad idea. But keep in mind that each question that I give you is going to have that same picture put up there for you, so it's not going to stick on each one. There's just no good way of doing this with formative. I wish there was, but if I put it in the text section and then add the questions, then you can't see it when we go here. All right, so look, question. A minus E, is it doable? Okay, why? Okay, what are the dimensions of A or E? 4 by 2. What are your answer dimensions going to be? What have I given you in terms of an array to write answers into? A 4 by 4. Are you trolling us? Sort of, yes. So here's the thing, right? You're only going to fill in what you need, which would be a 4 by 2, but you got to get them in the right place, right? So A11, or let's say, A1 or A11 minus E11 goes in your answer 11. Okay? And then A12 minus E12 goes in your answer 12. What goes in answer 13? Very good, Caitlin. Thank you. NA, right. You have to fill in all of the answer boxes, and so the ones that you don't use, you must fill in with NA. Now, this is going to become particularly important when we start multiplying matrices because you're going to have to be able to determine what the outcome dimensions are. It won't be the same. So in addition and subtraction, the outcome dimensions are the same. In multiplication, it's going to be different. And so you're going to have to be able to determine that. So I'm going to give you an array of at least the maximum amount. You're going to have to figure out which ones work and get the right numbers in the right place. Now, each question is worth 16 points, which means that all your NAs are also worth a point as well. So you should end up with 16 points when you get everything correct. Well, on the test, your question will be worth 10 points, and then it'll be graded on a rubric. And so, yes, I will determine whether how you maximized your usage of it. So, all right, how we doing? Everybody good? You understand what we're doing with these questions? Yeah. Make sense? Okay. All right, so these and the scalar multiplication questions will all be the same. The whole idea I wanted to go over with you here was just making sure you understand that not every answer box is going to contain an actual value. Those are going to come and be dictated to you by the problem, but you got to get them in the right places, and then you fill in all the other ones with NAs. All right, everybody good with that? Yeah. Okay, all right.